right, let me have your attention. Here we have a real life example. Okay? They're going to do lots of these type problems where they'll say you're finding the height of the building, or the height of the palm tree, or a flagpole, or the shadow. How long is the shadow? In geometry, the problems lend themselves a little bit more to real world examples. I'm just showing you on this first example, this is where we would actually use it. Surveyors might use it, engineers might use it. There's lots and lots of people that use trig functions on a daily basis. Architects, anybody that has to deal with drafting or measurements or things like that. So here we have a triangle. Inside, the ladder's leaning up against the house. It's 28 foot long. I have a 28 foot long extension ladder. You don't want to be 28 foot high on it. Okay, but let's just say that you're 28 foot high. You're asking how high up on the building, is the ladder. That's why the X is there. How high up on the building. Another thing you could ask is how far is the ladder from the bottom of the building. We could ask that. But right now, notice what they're giving you. You have a right triangle. You have an angle measurement, which we didn't have before. We have a length of one of the sides, and we're asking the length of the other side. Before today, the only way you could get to this is if you had two of the sides. I had to give you two sides of a right triangle in order for you to find the third side, right? How would you solve for this? What's that called? Pythagorean theorem, right? So if I gave you two sides of a right triangle, you could solve for the third side. If I gave you the hypotenuse and asked you what the leg was, you could solve for the leg using the Pythagorean theorem. Now we're moving into a whole new ball game with the trig functions. Okay? Now we're able to take one angle, one side, and find the other two sides. That's a huge improvement over the Pythagorean theorem because you have less information. Alright, so here we go. First step, can you see that? First step is to decide you can, or you can just do the triangle. First step is decide which trig function to use. Okay? It's probably the most important step. Obviously, if you don't use the right trig function, you're not going to get it right. How many choices do you have?
3.
You have 3. Right? I erased them, but let's write them down. You have the sine, which is opposite over hypotenuse. You have the cosine, which is what? Adjacent over hypotenuse. And you have tan, which is opposite over adjacent. Right? So those are your 3 choices. You can use sine, cosine, and tangent. How are you going to determine which trig function you're going to use? Mitchell?
What side you have and what side you're trying to solve.
Very good. The information that they're giving you. If I'm looking, I'll draw it like this.
So any side with the X, that's the side that will be on the top. So like that's the way. That's the
same
opposite.
thing.
So like if you're trying to find
No,
the
I'm saying that's
hypotenuse-
opposite, so you'd use sine, right?
All right. You're both. It
or
sounds like.
you could use sine or tangent.
Well, it sounds like both of you are on the right track. Let me explain it. Here's 50 degrees. The X is opposite of the 50 degrees, the angle that you know. Which one of these deals with opposites?
Sine again.
So it could either be sine or it could be tangent. The 28, what is it in relation to the 50? It's the hypotenuse, always, without a doubt. The 28 is the hypotenuse. Which one of these deals with opposite and hypotenuse? Sine, not sin, sine. So this is the one that we're going to use. We're going to use the sine of angle 50 in order to find x. And that's where your calculators come into play. So, step number 2, set it up. Step number 3, solve. There's not a whole lot of steps. Your calculator will do all the heavy number crunching. Okay? It's just deciding which trig function to use and then setting it up appropriately. Okay? So we figured out it's sine. We're going to do the sine of 50. How come it's the sine of 50 now? Well, because they gave you an angle. Because they gave you an angle, you can now say the sine of 50. The sine of 50, everybody type sine of 50 in your calculator. You're going to get some decimal, right? In the old days, you had to look in the back of your book and find that decimal in a chart, okay? Because calculators didn't have sine, cosine, and tangent on them. Okay, my parents paid $100 for a calculator in 1972 that plugged into the wall, and it did add, subtract, multiply, and divide. It didn't do sine, cosine, and tangent. It wasn't a scientific calculator. Now calculators know what that ratio is, the sine of 50, and all you have to do is type it in. What is the sine of 50 equal to? Here's the sine of 50. What is it equal to? X over 28. Opposite over hypotenuse. The opposite, now we have a ratio, a proportion, right? Sine of 50 is equal to x over 28. Now we can solve, right? How are we going to solve this? What if the problem looked like this? What would you do? How would you get x by itself? You'd multiply both sides by 2. So what are you going to do here in order to solve that problem? Multiply both sides by 28. You multiply this side by 28, and you can multiply that side by 28. Everybody get your calculator out. Practice. Type in 28 and then times sine of 50 and hit equals.
How many decimal places?
I want you to, if it doesn't specify, I want you to, hold on. If it doesn't specify, I want you to round like money. Okay? 21.45. Does that make sense that the height of the building would be 21.45?
No.
Yes.
Is 21.45 less than 28?
Yes.
Why does it have to be less than? Mitchell said it just a minute ago.
Hypotenuse is the biggest.
Oh yeah.
Say it again.
Hypotenuse is the biggest.
The hypotenuse is the largest side of the triangle. So this side here would have to be less than the hypotenuse.
Why is the
Okay.
ladder going up and it's 28?
It's 7
Oh, yeah,
and it's further with his house than his height.
That's right. As this distance increases, that number would get smaller. Okay, hold on. So let's review. First thing we had to do was decide which trig function. Is it always going to look like this? Is it always going to be sine? No, because they could have put the x there and asked you to find that x. Okay, then it would be cosine. You're exactly right. What if they put the 28 there and put the x there? Then what trig function would you have to use? Opposite and adjacent. Which one is opposite and adjacent? Tangent. So it all depends on what they give you, which trig function you're going to use. Okay? Then you have to set it up. Once you get it set up, once I get to sine of 50 equals x over 28, I'm home free. Okay? I can use my calculator from there. Now let me show you one more thing on that note. When you set it up, there's going to be some problems that look like this. Okay? Let's just say that, let's stick with those same numbers. Let's say that we set it up and we got x on the bottom. Some people don't know what to do when the x is on the bottom. Instead of trying to explain it and go, I'm sure somebody will ask why, but instead of trying to explain it, I'm just going to show you what to do. It's very easy. Those two values simply swap places. The sine of 50 comes down in the denominator, x comes up front. So this simply changes into x equals 28 over the sine of 50. When you're typing that in your calculator, you have to remember to use parentheses. Everybody practice. Get your calculator out and practice. Do 28 divided by the sine of 50.
36.55.
Say it again.
36.55.
Thank you very much. Okay, did anybody not get 36.55? Anybody not get 36.55? All right, you people with a graphing calculator need to make sure that you're in degrees and not radians. I'll show you how to do that in a second. Also, everybody else on your calculator, there's 3 little letters in the lower right-hand corner of your LCD screen. You must, every day, you must make sure that it says DEG. And I'll remind you on Friday before the test, but make sure your calculator says DEG in the upper right-hand corner. If for some reason it's in radians rather than degrees, you're going to get the wrong, it's just another measurement. You're going to get the wrong answer here. Okay, it has to be in degrees. And I'll show you your graphing calculators in just a second. All right, that's good. Thank you very much.